Hello there, I am Praveen Game. I welcome you all to software engineering and project management subject. Before going into the actual contents of the subject, let us see what the subject deals with, what are the contents and what are expected things in the subject. So as a prerequisite, we expect that you know fundamentals of programming languages. I hope you all remember something about these programming languages which you studied in your first year of engineering almost 2 years back. Then we have some course objectives. They are the objectives which are set by university. Subsequently, we'll see there may be some modifications or there may be some kind of changes in the objectives and outcomes. But let's see what we expect from the subject. To learn and understand the principles of software engineering, because we all are going to become software engineers. So in that case, we need to know what are the principles of software engineering. Second, to be acquainted with methods of capturing, specifying, visualizing, and analyzing software requirements, which are very much necessary for developing any software. Third, to apply design, testing principles to software project development, because whatever requirements we are having, we say we convert them into a design, we implement them, and we test these requirements. So for these things, we require to understand the design and testing principles for software project development. The latter part of the subject deals with project management. So in that case, the objective is to understand project management through life cycle of the project. So in this case, we'll be seeing subsequently we'll be seeing uh, software development life cycles and other things, and which will be used for management of a project. And to understand software quality attributes, because whenever we are building something as a software engineer, what will come out is a product, and always a product carries quality attributes. So we need to understand what quality attributes are expected by the person who is going to use it, or by the person who is going to who will be your customer as such. As outcomes, uh, once you complete this course, it is expected that we'll be able to decide on a process model for developing a software project. So once you understand the principles, you know the principles of software engineering, you know principles of design, you know principles of testing. Then once having this knowledge, you should be able to decide which process model to be used for developing a software project. Second, we're going to see various applications. So in that case, you will be able to classify in which category of applications my current software comes into. Okay. So that we're going to see in the software applications, classification of software applications, and identify unique features of various domains, because softwares are being used in every domain nowadays. So in that case, we need to understand what kind of uh, features are there in every domain. Design test cases of software system, because obviously we're going to use these softwares for some purpose. So for the purpose is defined in the software requirements, and for those requirements we're going to design test cases. So we should be able to design the test cases and test the software for various functionalities. Then understand basics of IT project management, because as a software engineer you're going to be working in software industries, and there obviously we require to know what is project management. Earlier, you may be joining just as a coder or tester. However, subsequently, as you rise up in the organization, you're going to become project manager one day. So, in that case, you need to know what is project management. Then, plan, schedule, execute a project considering the risk management. Every project carries some kind of a risk. Any product, it may be a software product or it may be any other product, there are certain risks associated with every product. So as a software engineer, we need to understand what are the various risks present in the software product, and accordingly we can for those risks, we can identify the risk, and we can do some kind of a management of those risks, so that as and when this risk arises, as and when the change comes up, okay, we are able to deal with those risks. And lastly, apply quality attributes in software development life cycle. But as we mentioned, every domain will have some kind of a quality attributes. Every product will have some quality attributes. And when we are given a product, we need to we should be able to apply these quality attributes. So this may be a performance, it may be a correctness, it may be a, if it's a visual product, it may be a visibility, how the product is being seen, resolution, and how it fits into various things. If it's a product which is supposed to work on multiple platforms, then it should be we should be able to deal with, or we should be able to render this software in multiple platforms. Okay, so these are various outcomes and objectives of the course. Now let's see the contents of the syllabus. Okay, so the subject is divided into 6 units. Every unit is will be covered in around 7 or 8 lectures. So the first unit, which talks of introduction to software engineering and software process models. So in this unit, we'll be covering various fundamentals of software engineering, in which we'll be seeing some principles as we mentioned in the objectives and outcomes. We'll be seeing some software principles, so what is software process, certain things about software. There are many myths about software. We'll see those. It also covers various process models. So we're seeing, you must have heard something called as waterfall model in your earlier days. So we'll be seeing some process models starting with waterfall model and some other process models we'll see. Then it also covers some advanced process models which are currently being used, or which are very famous, we can say, in the current days, which is called as agile software development or agile software processes. So that will be covered in the first unit of your syllabus. Second unit covers or talks about software requirements, engineering and analysis. So this basically deals with the requirements. Okay. So we know when any software is being built, the software has some kind of a requirements. Everything that is built has some need, has some necessity, has some requirements. Okay. So for softwares also, we have some kind of a requirements. So we need to identify what are the requirements. Okay. Now if you see, just for an example, if we want to build a calculator, you have done many programs in your first year engineering, second engineering, I know. So whenever we are given a product, or whenever we are given a problem statement, we first identify what is the need, and whether it is given like to develop or to implement a calculator program. Given these things, that means we have some requirements. What are the requirements for developing a software for software for a calculator? We require to understand that a calculator consists of basically 4 functionalities. It may be algebraic functions, okay, like say addition, subtraction, multiplication, division. Now with these 4 functions, we can build a calculator. So these are the requirements. So first we need to identify what are the requirements for my software. That we will discuss in first chapter. Just identification of requirements is not sufficient. We have to analyze the requirements. Analyze the requirements for their correctness, for their completeness, for their precision, whether they have been properly defined or not. So these things will be covered in the second unit of the subject. Third unit talks of design engineering. Okay. In this unit, we're going to discuss about some design models. Now, whenever we are having design, so just for an example, the analogy which generally is given is we always have some kind of a design. Okay. So, given a requirement, we convert these requirements into a design. Okay. Like if somebody wants to build a house, what we have, we get requirements. Yes, I require a house which is of say 1 bedroom, 1 hall, 1 kitchen, and other requirements in the house. So what is the space first? So taking the space, and in that space I want to fit this house. What is being built or what is being designed first is the layout of the house. So I hope you know this term. There's something called as blueprint. So blueprint of the house is a design of house, getting considering the requirements with the required space. This should be the area of the bedroom. This should be the area of my kitchen. This should be area of my hall, and whatever area remains, how to be utilized. So for all these things, with these requirements, we have to build a design. So every house has a design. Similarly, every software product, when requirements are received, it's converted into a design. Okay. So for this design, we're going to see various types of design models. Okay? Because it's not that now we can just convert the requirements into some kind of diagrams. Okay, we need to identify what kind of designs are required, because various projects will have different kinds of say requirements are there. So in that case, it needs to be fitted into some kind of a product or some kind of a design model. So for this, we're going to see some models. So models may be design models, and various design models are available, like architectural designs. We may have component level designs. You may have user interface design. So these are various design things which will be seen in this third chapter. Fourth chapter will deal with the project management concepts. So considering that half part is given to software engineering, and next 3 units are given for management activities of the project. So here we are going to again see what are the various processes, metrics, estimations and risks that are involved in the project and which needs to be managed. So we'll be seeing some management concepts in this, how to estimate a project. So for which we're going to see different estimation methodologies to identify that this project is going to take this much amount of time, this much amount of human resources, and this much amount of say cost will be required. So cost estimations and human requirement estimations, human and non-human resource requirements will be identified or estimated in this chapter number 4, unit number 4. And then the next unit talks about risk management, configuration management, maintenance, and re-engineering. Because project no, developing software engineering is not just dealing with a building of a project. It also deals with once the project is ready, or during the say life of a project, till the time project is ready, we will be coming across with many risks which needs to be managed. Now once the product is ready and is given to the customers, that time also there may be certain risk. It may be just for an example, like we developed a product say for Windows 7. When Windows 10 comes up, it may be the case that some of the components of my product needs to be changed so that they fit into Windows 10. Obviously, there is something called as backward compatibility and other things are there. However, I'm just giving an example that there will be some kind of a risk like this. Or if you want to build something called as platform independent, okay? However, there are some components which are not going to match with some kind of operating systems, which needs to be patched subsequently. Okay? So this will keep on happening in the life of the that software as such. Okay? So software project management not only deals with now building the product, but also after delivering the product, its maintenance and re-engineering that is required. Okay? So all those things will be covered in unit 5, and unit 6 will be covering software testing. So as we mentioned that we are going to take the requirements, then obviously these requirements will be converted into a design. From the design, we're going to implement these things. After implementation, we're going to test these things. So for this testing, there are various principles of testing, various testing methods like black box testing, white box testing, unit testing, integration testing, system testing, performance testings. There may be some performance requirements, there may be some non-performance requirements. Okay? So for this NFRs and performance requirements, testing has to be done. Every product that is given before giving it to the customer, it needs to be tested. Okay? So obviously, if you see any hardware product, any software product, generally we see it on the hardware as such. Okay? If you take just turn around and you just see the back side of it, it says tested OK. Okay? That means the product is tested. Same thing applies to softwares also. Okay? All softwares that come in a user's hand are tested first. Okay? So as a software engineer, it's our responsibility, whatever we develop, whatever we engineer, it should be tested. Okay? So that testing will be seen in the last unit, that is called as software testing. So those things will be covered in software testing part. We'll be basically referring these two books. One is by Roger Pressman. Roger Pressman is a well-known name in software engineering discipline, and I hope you must have heard at some point of other point of a time in your life. Roger Pressman is this book is there in this since last 30 years at least, because we also use this book. This book was there before I studied engineering and is still there. Okay? So now the editions have been changed. Maybe there may be ninth or 10th editions available. However, we are referring to an edition which is 7. Sometimes I'll be referring to the higher editions too. However, we are having the 7th edition in the syllabus. And second book is Ian Somerville. So these two books are the basic books for us, and reference books I'll be referring sometimes, but not say not that frequently. Most of our contents will be covered from these two books, Roger Pressman and Ian Somerville. So now we'll be going to the subject as such. I hope these things are clear. This is to just to give you an understanding that what subject is, what are the contents of the subject, what is expected, that is objectives of the course, and how what is expected from you once you study the subject. Okay, now as we have seen the contents and requirements, now let's delve into what the subject is. Okay. So we are starting with software engineering fundamentals. Before going into details, we'll see what this software engineering is. Okay. So the subject is having these four terms. Okay. The first is software engineering, project, and management. Now let's see, or we will try to define each of these terms. I have given more definitions. I'm just putting one definition here. Now let's see what software means. I hope you know the software definition as such. You are using software every day. So to define a software, it's the programs used by a computer for doing particular jobs. That's what we are calling right now as a software. There are many definitions, and I hope you everybody will have some kind of a definition. Like when if you ask me what is software, I'll say anything in the computer which is not a hardware is a software. So everybody will have a different kind of definition, but for us, we'll be using this definition: the programs used by a computer for doing particular jobs. Second is engineering. I hope now you know definition of engineering: the study of the design, building, and use of engines, machines, and structures. Okay, this is the this is what is expected as an engineering. Okay, now for us as a software engineers, we are going to definitely design, we are going to definitely build. Now what is the use of engines? So engines, it may be using the tools which are already existing. Okay? Use of engines, machines, and structures. So this is where we can say we can have the models that are existing. We'll be using some kind of design models. We may be having some kind of a say collection models, data collection models, requirement collection models. Okay, so these are the engines through which we're going to collect the requirements, we're going to design the requirements, we're going to design the software, then we're going to build the software. Okay? And obviously machines in our case will be computers. We're going to use a computer system. Okay? And then structures obviously. So we'll be seeing various things. So this definition of engineering also fits for us because we are also going to become software engineers. Okay, so in our case we can say that software engineer is the one who is going to develop programs, okay, by using the various methodologies in engineering. That is, he's going to design the program, he's going to build the program by using computers for performing specific jobs. Now what is a project? Simply to say, it's a piece of work planned to achieve a particular aim. For software engineers, project may always mean a software project. However, a project is always a piece of work that is planned that is planned to achieve a particular aim. Because that's what we say software is for doing a particular job. So project is also similar kind of a thing. And then management, obviously the act of managing. We're going to manage the project, we're going to manage the software development, to manage the software design, manage the requirements, manage the risk, manage testing. So there are a lot of management things are there in in a software project. So we're going to deal with these four things: software, engineering, project, and management. Okay. Now a little more about software. A computer software is the product that software professionals build and then support over the long term. That's what we call as software. Software is not just having something, having some program and let the program run and I'll say, okay, my software is ready. It's not the only case. Software is a product which is built as well as supported over the long term, means over the life of that software. We're going to see that software also has some kind of life. Software takes birth, it remains for some time, okay, in which case we maintain the software. So it has its life, and obviously it starts deteriorating. After some time, we say it's become obsolete. Okay. So like we also have this kind of a things. The software also has the life, okay, or life cycle we can say. Okay. So what it encompasses? The software encompasses programs that execute within a computer of any size and architecture. Okay. Now this depends obviously, the program has to be built for something. So when you say architecture, I cannot run an Android program on a Windows machine. So there are different ways to do certain things. When we are saying programs that are executing within a computer of any size and architecture, so this is to say that what is a software? Software is any program in that case which is running in any computer. It may be a mobile phone, it may be a tablet, it may be a web based, it may be a computer, it may be a washing machine, okay, wherein there is a program available. Okay. So programs wherever they're being executed. Okay. Content that is presented as a computer program executes. Okay. So this is where this is a second place. So not only programs but the contents are also part of a software. Okay. That are presented as a computer program execute. Okay. Third is descriptive information in both hard copy and virtual forms that encompass virtually any electronic media. Okay. So this is also software. So three things will be covered in a we will say are part of our software. First is a program. Any program is a software. Second component is content that is presented to the user, and third is a descriptive information. It may be a comments also. Okay. Like when you run a program, it displays on a screen something, okay, or something is being shown on a screen. Like right now you are seeing me on the system. Okay. So in that case, I am a content. Okay. When you are seeing a slide here, it's a content. Okay. And then there is descriptive information, because for any software, the software comes with a manual. So anything, any product will come with a manual. So it may be a hard copy manual or it may be a soft copy manual, that is virtual forms are there. So obviously we say we are downloading some kind of a software. So it's a virtual form. Anyways, software we generally say it's a tangential, it's not tangential, it's not physical. Okay? We'll see certain things about it subsequently. But right now just understand that three things about software: programs, contents, and descriptive information. Okay? Now the question comes, who built? Now that we know what is a software, there are certain questions. Who builds the software? Obviously, a software engineer or a computer engineer is going to build the software. Any steps? Definitely. There are certain steps, like already mentioned. We have requirements. We need to collect the requirements, design the software, implement the software, and then test the software. After that, maintain the software. Okay. So there are various steps that are involved. Okay. Now within these, there are the 5 basic steps we can say, or broad steps. Within each of these, there will be multiple steps. Okay. So definitely, there are steps involved in development of a software. Okay. And then, what is the importance of software? We're going to see what is the importance of software. I hope you all know that softwares are very much important. Okay. Now let's see. That's a fact. Our world without software. So I'm just showing you a black box. Okay? The black box doesn't mean that it's going to absorb everything. I'm showing the black box to mean that my world without software is a dark place, a black dark place. Okay? I can't have anything. Okay? It's a rude fact. I'm mentioning it's a real rude fact. Our world without software is a deep, dark, black world. Okay, I can't have anything. Okay? You may not be seeing me, okay? Or you may not be having a mobile phone. You don't have washing machine. You cannot have a oven. You cannot have your nowadays a car also has a software. Now software is there everywhere around us. Okay? So my world without software, at least now I cannot see. Because if you ask me 15 years back, 20 years back, okay, maybe the case that yes, that time I would might have said that software maybe something is there, but not that important to me as such. However, today software has become life. Everybody requires software. Can somebody tell me where software is not required? Maybe only in the cases where say we are not using any electronic device. At that place you can say I don't have a software. Or you if you are still using the lock and key to the houses, I may not have a software. However, for day to day life, as soon as I get up early in the morning, I get up by hearing an alarm. Now, this alarm earlier was being given by a watch. Now, I have alarm set up in a mobile phone, and it is a software. So, my day starts with the software. I keep on checking the mails, sending the mails. I don't write nowadays a mail or letter and send it. I just write a mail and send it. The mail is gone. The mail is sent. So sending mails, receiving mails, talking with someone, I'm using a software. So apart from the electronics, we have a software in that. So mobile phone, why I'm giving you an example of mobile phone? Because I may not be carrying a pen today, but I'll be carrying a mobile phone and which is full of softwares. If I want to present something, I have software. You want to learn something, learning through software. Online, software. Offline, whatever machines, embedded systems, IoT, cloud, whatever you are seeing today is nothing but software. Obviously, there is some hardware, but hardware cannot function without software. Okay? Just giving an analogy of life, like we as a body is a hardware, and there is something called as consciousness in the body, and that consciousness is nothing but a software. If that consciousness is not there, this body is just a hardware, which is dead hardware. So, if for my body, you may call it a soul. If there is no soul, there is no software. If there is no consciousness, which is a software, this body is no better than a dead body. Similarly, any hardware without having a trace of a software is a dead thing. It's not of any use. There is no difference between a chair and a computer without having a hardware. I need to have hardware. You may be having the latest of the processors. You may say I have i7 10 generation, or you may be saying that I have a GPU, or you may say I have a CUDA, you may say I have a supercomputer, but there is no software. It's of no use. That's the importance of software. Our life without software is not going to take me anywhere. Obviously, you all know that this is the era of COVID, and everything is being done is online, wherein softwares are being used. Okay, some more things we'll see about the importance of software. Okay, why is required? Why it is important? So see here, computer software continues to be the single most important technology on the world stage. Now, every country, though it says that we are running something on every country has a contribution of something or other. However, if you see the countries like India, We though we say we are agriculture based countries, however most of our revenue nowadays, most of our employment is in technology, is in software field. So India per se, so from 1983 when the computer engineering came into, say, in India, before that also it was there in the world stage. However, uh, to say that in India, 1983 was the year from when computer engineering started entering into our engineering domains. Okay? Otherwise, we had the core engineering domains were there. So from that time onwards, if you see, the developments have started in the computer engineering. So we have a lot of computer engineers coming up and a lot of computer industries, IT industries that we see are our single most important technology on the world stage. We want to convert everything into software. Nowadays, if you are seeing, we are having something called as automation. We want to convert everything into automation, automate the things. What is the meaning of automation? We just want to convert that process which is done manually into a software. Maybe done by a robot, but it is a process, it's a software. It will be a product which is built by using a software. So that's where we are seeing that's the importance of software engineering as such, okay? Or software. Everywhere we have softwares around. So just giving an example, everybody knows about Google. What is Google? It's a software. Any problem you are having, anything you don't know, what you do first is you do Google. So now that's the source of information we say. Somewhere the software, somewhere the documents are stored, somewhere there are some pages are available, some information is available, and we Google it. Okay? That's using a software. Right? So if you see 50 years ago, no one could have predicted that software would do so many things. Okay? So obviously 50 years is a long time, we are saying. So we're in 2020. So in 1970s, if somebody would have asked us, or somebody would have, whoever was the president at that time, that what is a software, would like to use some kind of a software, he would have just ran away. Like you know that when this Turing was performing the experiment of testing certain things, he used to call one person and ask him to sit in another room. The person is to run away. What is this person is trying to do with me? There is to be cameras. If this person is, you ask him, I will take your photograph. The person will run away. Okay? So something like that might have been the case that 50 years ago nobody would know that software. There will be something called as software. The term software itself might not be there as such. Okay? So what software will is doing today is not known as such around 50 years back. So nobody would have thought that software will become today an indispensable technology. Like we mentioned that without software, our world is just blackout. There will be just blackout. Enable the creation of new, extension of existing, and change of old technologies. So software, it's in one sense I can say it's most malleable. You can change a lot of things. Okay? You can create new things, you can extend the existing things, and you can change the old technologies. Okay? So software, as we know, it keeps on changing. Okay? It keeps on changing. Every day we have newer and newer things coming up. Okay? So there is no more Moore's law for softwares as such. Okay? Softwares are being changed dramatically, okay? Because everybody is trying to build the softwares, and in the age of open source, we are seeing so many softwares coming up for different things. Like I'm using one software for recording my videos, somebody else may be using other software, somebody else may be using other softwares. So there are hundreds of softwares available for doing a single job, and everybody is trying to say that yes, this is the better than this is better than this, these are our features, these are our quality attributes are there. So similarly, if you are seeing that we are using so many tools for meetings, we have Zoom, we have Teams, we have Meet, we have Duo. So there are different things are being built, not only by different parties, same parties are also different building different tools. Like Google has Duo, Google also has Meets. Okay? So everything is being built with some kind of features. So that's where it software allows us to change certain things. Obviously, software is a driving force behind the revolution of PCs. Okay? Softwares are the driving force behind PC revolution. Okay? So earlier, if you see, we had big machines were there, room filled of a single machine, or a computer of a size of a room. That was the personal computer as such. Now what we have is we are sitting in a room, or with say 10 or 15 people can 10 or 15 people can sit in a single room, which each with a different kind of a PC. Okay, so in PC we see that earlier we had the DOS was there, then Windows came, now we have Linux. So software is a driving force behind the revolution of uh, PCs. Okay? And software would evolve from product to service. Earlier, if you see that the software was being built, or software was being just considered as a product, okay? Build something as a product and provide it, and people or users will use that product and and just use it as such. Okay. However, now we are seeing the change. Software is not just a product; it's also a service. Okay. So, if you see India, what India does or Indian IT industry does is it provides services. It provides service. It may be a maintenance service for software. I'm saying, okay, and softwares are providing all various kinds of services, not just a product. Okay? So obviously, service is coming on top of product. There is a product, and then for the product we have different kinds of services. Apart from that, it's also like we say YouTube. YouTube is a streaming service. However, there is a product YouTube somewhere available, and we as a user, what we are doing is we are just using this software as a service. Okay? So I hope you are well known about you have all information about this clouds also. So there is one term comes as a software as a service. Okay? So SaaS we say SaaS, software as a service. So it has evolved from a product to a service. And again, nobody would thought that 50 years ago that software would lead to build companies larger and more influential than any other industry. So if you see today, the revenue generated by the software industries is the maximum. You take the names who are the richest people in the world. Okay? We generally say it's a Bill Gates, who is the owner of a big company, so Microsoft. Then nowadays you say Amazon. Okay? Amazon is software, correct? The owner of Amazon is also one of the richest person. Okay? So this rich, or no, not I'm just taking the example of rich assets, but the industries we are seeing, the software industries are the largest. The maximum man force nowadays is required in the software industry. So we have maximum employment in software industry. We have maximum revenues coming from software industries. And if you see the education also, education is largely affected by softwares. We have softwares for education. Now, now when we are going through this lockdown phase, we know that we learn through a software. We are learning through a software. And the last part that nobody would thought 50 years ago that the softwares will become an embedded in all kinds of system. Okay? So embedded system term is there, but what is embedded in that is software. We have a hardware, and in the hardware there is a memory. There is a hardware memory as well. Okay? There is some memory is there. Okay? It's called as ROM generally we say, or flash memory is there, and there we embed the software. So what we are having is an embedded system. When we say embedded system, what is embedded is a software. So whether it's a real time, whether it's an embedded, what we have is a software present there. So that's where we are seeing that 50 years before, nobody would have thought that these six things would have been there as such. Okay? However, nowadays we are seeing that this has become a life. It's a part of our life as such. Okay? Software has become part of our life. Okay? Now, once we have seen the software, we have mentioned earlier a small definition of software. Now we are going to give you a detailed definition of software or a very standard definition of software. Okay? Let's see what it is. Okay? The product that software professionals build and then support over the long term. That's what we defined earlier. What it encompasses? We mentioned three things earlier. that it is program, there are contents, and there are some descriptions are there, giving it a more definition type as such, okay, or a formal definition of a software. It encompasses instructions, okay, computer programs. We know when we define a program, or so we define a process. So what is a process? A program in execution is a process. Okay. What is program? Program is set of instructions. Okay. So obviously we have instructions. So software encompasses instructions that when executed provide desired features, functions and performance. Like we mentioned, if you have a product, if you have software of calculator, so in that case there are instructions. Instructions may be we switch on first, so there will be a button. If that is pressed, the instruction is on the button press, turn on. Okay. So my calculator is now on. Now it's waiting for input. So we enter some digits. So as and when the digits are pressed, the digits are entered. So it's waiting. So if there is instructions, input number. So it's waiting for getting that number. So taking you to the programming languages that you are known, like in C, we say scanf or printf. Now there is no printf as such which will say here enter first number as such. However, from seeing the screen you know that I am supposed to enter some kind of a number. So you enter the number. Okay? When that number is entered and then you press the plus sign, it takes the first number. Okay, that means the instruction is read first number and the operation. Now we are waiting. The computer is this calculator program is waiting for second number. Now you type the second number and then you press equal to. So there are instructions. Now it has first read the first number, read the operation to be performed, read second number and give the result. So A plus B is equal to C. That's what is being performed. So scanf A or scan A, scan operation, scanf B and do the summation operation. 4 instructions are being executed. Okay. So that's what first thing we have instructions. Second is data structures that enable the programs to adequately store and manipulate information. So you are having a separate subject for data structures wherein you study how this is stored in some kind of data structure. I take an integer number, how it will be stored. I take the operations. Okay, so for which then you need to perform the regular expressions and different things are there in data structures using which we store the given information in data structure and we process these data structures to get the results. And last thing, documentation that describes the operation and use of the programs. So when you are writing a program, you do comment there. Okay? We say in good programming practices that you have studied in your FPL, they mention that in good coding practices, one should write the comment. So when you say scanf and you say A is there, you're trying to get the number A, first number from the user, there you can write a comment, enter, or you say the program is asking the user to enter first number. Operation, what is the operation is to be performed? So it's addition operation. So you write there addition operation is to be performed. Second number, and when you say sum is there, the sum of the first and second number will be given as an output in the variable C. So we do comment in coding, and obviously that's for the other software engineer as such who is going to subsequently say maintain or manipulate or change or modify this given program, for which we write the comments. Otherwise we provide a documentation on how to use this software. Okay, so there is a description that comes up generally, like we say when we get a washing machine, it comes with a manual, so it mentions that what all functions are available. Okay. So for the user, what is required to be known is provided in the manual of that software or product. Okay. However, documentation that comes with the software, there are various kinds of documentation that may come up. Like say for software, it may come as a requirement documentation. So I may have requirement documentation, I may have design documentation, I may have implementation documentation, then I will have testing documentation and management documentation, change management documentation. So various kinds of documentations that will come up along with the software. Okay. So wherever it is being built, these things will be present. Now apart from that, we also say the software is having two kinds of roles as such. Okay, we say software is both, it's a product as well as a vehicle that delivers a product. Okay? So we are saying that as a software engineers, we are building a software, we are building a product. Okay, so first thing, we are building a product. Okay? That means software is a product. No, done. Now, second thing is, how will you build a software? To build a software, we use some kind of things, like we use a programming language. If I'm using C as a programming language, or Python as a programming language to build some kind of a software, that means that is a vehicle to build that product. First thing. Okay? So I have some kind of IDE, which is again, which IDE itself is a product which is developed using a say software. So, but once it is ready, it becomes my vehicle for delivering some other products. Okay? So once I have Anaconda is there with me, and I go to Spider. Okay, so Spider is an IDE in which I can write different kinds of programs, and I can build the product, I can test the product, I can write comments in the product, I can document it. I have various data structures available in that. So I build the software there, I do documentation, I make the software ready in Spider, and once it is ready, I send it for say use it by the user. Okay? So software is both, it's a vehicle as well as a product which will deliver the product as such. Okay, so both things, both roles are there. So as when we say what is the role of a software, we generally say it's both roles. So it's not that only developing a product is software, it also acts as a vehicle that is going to deliver the product. Okay, now once we have the product is ready, way to know, like we mentioned in earlier earlier also, we need to identify what are the quality attributes for a software. Okay? So when you say I'm building a software, I need to identify what all essential qualities, essential attributes are there, so that I can call a software as a good software. Okay? So we are mentioning some here. So I'm not saying that these are the only ones which which are the good software or good attributes or quality attributes as such. You can add more. However, these are the ones which should be there. So we always say that there is something called as necessary, there is something called optional. So what characteristics I'm listing out here are the ones which are necessary ones. Okay? Now the first is maintainability. Any software that is built, okay, has to be is it needs to be maintainable. Okay? Now see, what we call as a maintainable means software should be written in such a way so that it can evolve to meet the changing needs of the customers, because we know that uh, a software which is built for one person may not suit for other person. He may not require all functionalities, he may require some additional functionalities. So there are always some kind of a changes from customer to customer. Software may be one. Okay, so like we say in Windows, it provides us a calculator. Now how many calculators are there? There may be a scientific calculator, there may be a just simple calculator, and there are three or four more options may be present uh, in calculator itself. Okay? So when a person is writing a software, he should write it in such a way that it is maintainable. It is capable of accommodating the changes which the customer asks for. So this is very critical attribute because software change is inevitable requirement of changing business environment. This is very much required in that case. Second, dependability and security. Obviously, this is very much required because whenever we are having any product which we say we should be, it should be dependable. We are dependable on that software. Okay? So uh, what generally what dependability means is that we say it should be reliable. We require two things, and a software will be looking for two things. One is it's reliable, it's available, as and when we require it, it should be available, it should be secure. Now it is very much required that every software should provide me security. Like if you want to do something online banking, you want to perform, you are going to use a software, browser based software or web based software you are going to use, which comes in your web page. you may be using any kind of a say you may be using Chrome, you may be using Firefox, you may be using Explorer. What we expect is not only that this Chrome has to be secure. I'm using a connection which is also by using a software, by using a protocol which is software, has to be secure. Then at other end, at the banking end, there also I expect that there has to be some kind of a security. So I expect certain attributes as a dependable software. I expect it should be reliable, which is always the case. We always say, okay, that person is not reliable, that person is not trustworthy. Similarly, a software has to be a trustworthy. Human race as such, if you see, it requires trustworthiness, it requires reliability to sustain. So whatever we are using, we are asking for reliability, we are asking for availability, we are asking for trustworthiness. So same thing for softwares also. A software dependability includes a range of characteristics including reliability, security, and safety. Then what we call as a dependable software? Dependable software should not cause physical or economical damage in the event of system failures. That's very much required, because if software fails and if you say, okay, whatever money transaction you have performed is lost. I tried to transfer some amount of money from my account to say your account. So in that case, if the transaction fails, software fails, on one end it says amount debited. This many times we have faced. I suppose you must have faced this also when you use the ATM. Money is not coming out, but it says you get a debit slip. Money is debited. You get SMS also. 1,000 rupees debited. What to do? I haven't got the money, boss. What shall I do? Wait. They have done, or there is something called as rollback. So they roll back a transaction. So even if the software has failed, even if the transaction has failed, it is noted, and I make it sure that I'm dependable on ATM machines. If tomorrow you say that once the machine says that you got the money, even if the money has not come out from the machine and it's considered the transaction is done, I'm not going to use ATM machines. That's why I'm saying that we, as a human race, we require that kind of a trustworthiness, not only on humans, but also on machines, because we have a nature of doubting. We doubt. We doubt for everything. So same for thing applies for softwares also. We doubt. That's why it's a job of software engineer to provide a reliable, secure, safe software. Because as there are good people, there are also bad people. We call them as malicious users. So these malicious users should not be able to access or damage the system. That is what we expect from the software. Okay. Next thing, efficiency. We expect that software should not be crawling. It should not make my things slower than it can be done by a manual activity. I want to use software so that it becomes, or it is faster than the manual activity. So that's what I am expecting from a software. It should be efficient. Okay? So software should not make wasteful use of system resources such as memory and processor cycles. So apart from becoming slow, it should not unnecessarily consume my resources, because resources are always costlier. My processor cycles, my memory, this my means my this computer is saying that this software is doing a small job but using large memory, using large processing cycles. So the computer will not like to have this kind of a softwares. Neither the humans would like to have, neither users would like to have, because as soon as it starts consuming more memory, it takes more processing cycles. That means it's taking more time to give me the output or to give me the results. In that case, efficiency is very poor. So we want a higher efficiency. We want better efficiencies. So efficiency therefore includes responsiveness, processing time, memory utilization, processor utilization, or what you say is throughput. So I need to have this kind of attributes for defining efficiency of a software. Next, acceptability. Software must be acceptable to the type of users for which it is designed. So if you are using a calculator For a kirana store person, for a grocer, he doesn't require a scientific calculator that like the one you use. He just requires a simple software. What he requires is a the software, the calculator which will perform plus minus. At max, he require say multiplication and division, because if he is giving some kind of a discounts, he may have to calculate those discounts. So in that case, he will require a software which is having these four kinds of functions. However, as engineers, you must have used in first year, you require a scientific calculator. Now there also we say you are not supposed to use a programmable soft calculator. Getting? Now every user has different kind of a demand. Software is same, it's a calculator. But as a user, for a grocer or for a medical shop owner, he has a different requirement of a software calculator than a first year engineer student, than a person who has already become an engineer and he wants to use for scientific calculations. So three different users are there, three different types of requirements, three different types of cost will be there. The simple calculator will be costing very less. Scientific calculator maybe 1,000, and a calculator which is programmable may be costing more than that. So the size changes as the requirements change, the cost change, size changes, the functionality changes. Okay? So for every user, it must be acceptable. So acceptability may have different kinds of then say attributes. It may be a cost, it may be requirements, it may be functionality. Okay? So obviously, a scientific calculator can perform the jobs of a programmable calculator can perform a job of a scientific calculator also, and a simple calculator too. However, a simple calculator will not perform the job of a scientific calculator. So that will be present as such. So software, you need to identify the user requirements. Based on the user requirements and his what you say is uh, mm, budgetary requirements also, we build the software, we deliver the software. Okay? So this means that it must be understandable, because if you give a simple calculator, if you give a scientific calculator to a say grocer shop, he may not be able to use it. There, you may press some kind of a button and suddenly he will see everything as a binary. Come on, he doesn't know what is binary as such. He just know the numbers from 0 to 9. Okay, he doesn't know what is binary, what is hexadecimal. So in that case, he doesn't require those things. He will not be able to understand those things. So we need to provide a software which is understandable by the user as such. It should be usable by that person and should be compatible with other systems that they are using. So I give the example of calculator, which is a very simple one for everyone to use. However, if you take different kinds of softwares, there will be different kinds of users accordingly. Okay? So depending on the users, we have different kinds of requirements, we have different kinds of things. Okay? So these are various attributes that should be present with every software as such. Okay? Not requirements, we'll say it's attributes or quality attributes, features, characteristics that should be present with every good software. You can add more to it, or you can include other attributes into these four categories also. Okay? So understand this. What we have seen today is we have seen the software, what is software means, what it includes, and various attributes of a good software. So we'll stop here for the first class, and then we'll meet again in the next class with the new or subsequent contents. Thank you very much for listening. Have a good day. Bye bye.